Welcome to QuickSWIP's online video series. In this video, we'll discuss onboarding and staff training for QuickSWIP's field technicians. In this section, we're going to discuss a document that we have here in QuickSWIP. It's called the QSP cheat sheet. And what that document does is it helps a QSP quickly go back and review important items that is vital to their job and their roles and responsibilities. I'm going to be speaking about the different risk levels associated with a SWIP. And for someone who doesn't have any idea of SWIP or this is new to them, there are 3 different risk levels associated with a SWIP. And it is the QSD's role and responsibility to determine what the risk level is for a specific project. All projects are different, and the risk level is based upon the construction schedule, so whether it goes through a rainy season or not. It is based on the topography of the site. So if it's on a hillside and you have way more chance of, or a higher likelihood of sediment leaving your site, your risk level can go up. Also, what kind of soils are on site. Typically in the Bay Area, your soil profile is more or less the same, so that's not such an issue, but throughout the state of California and throughout the United States, soil profiles change. Again, it has to be determined and calculated, so it's not a boilerplate number. The last part of the risk calculation is what's called the receiving water body. So where does the stormwater flow when it leaves your site? And if it flows to a water body, a creek, stream, ocean that is currently impacted, and impacted could be via 4 different things. If it's impacted for sediment, it has an existing sediment issue or problem has been determined, or if it is a spawn, cold, or migratory, it has to be all 3, spawn, cold, and migratory habitat for wildlife microorganisms. So those are the items that determine what the risk level is. So there are 3 risk levels that a SWIP project can have, and they start at 1, 2, and 3. 1 requires the least amount of testing and requirements. 2 is the intermediary, and 3 requires the absolute most. To be honest, we rarely come across risk level 3 projects. They are unique projects and they require a whole different set of testing requirements, including bioassessment. So you have to, typically what we recommend is hiring a biologist on the team as well to be able to take all the proper samples and understand exactly what we're looking for when we are assessing the bioactivity of the receiving water body. Risk level 1 does not require testing in typical stormwater or typical storm situations. And risk level 2 requires pH and turbidity testing, which we'll discuss further. As I discussed, the majority of sites that QuickSWIP has are risk level 1 or risk level 2 projects. I'm going to go into a little bit more depth into what's required for risk level 1 and risk level 2 project. Again, all this information is within the QSP cheat sheet document that any QSP or QuickSWIP staff can access at any time. As a risk level 1 project, there are requirements that the QSP must complete to keep the project in compliance. And those requirements really come down to reporting requirements. So a risk level 1 project requires weekly inspection reports. It does not matter if it's raining or not raining. It requires weekly inspection reports. I can't tell you how many times I go to a site and the site superintendent or our client on site says, "What are you guys doing out here? It's not raining." That used to be how the SWIP requirements operated, but as time passed and requirements got more stringent, the weekly inspection requirement is a staple and is required no matter what, whether it's raining or not. There are pre-storm inspections that need to be done. there are during storm inspections, and there are post-storm inspections. Now, unlike a risk level 2 where you actually have to do sampling, on risk level 1 projects, what you're doing typically is visual inspections. So you're going to do a pre-storm visual inspection. You're going to do storm visual inspections. And those visual inspections can be, are we looking for turbid water leaving our site? It's very easy to see with your eyes. It looks like clear water leaving the site. And you'll do a post-storm inspection if there was more than half an inch of rain for that storm. So a storm is categorized as less than 48 hours of rain between precipitation. So let's say it rained on Monday, took a break on Tuesday, rained on Wednesday. That's still the same storm because it was less than a 48-hour break. So we'll discuss later and via the QSP cheat sheet how you can determine the precipitation amounts on a construction site. But that's a little background into how you determine if you have to go do a post-storm inspection. The other type of construction projects we have are risk level 2 projects. Now, risk level 2 projects are the exact same thing. They require weekly inspections, pre-storm inspections, storm inspections, and post-storm inspections. The number one difference between a risk level 1 and 2 is the fact that during a storm inspection, you must do pH and turbidity testing on the storm water that is leaving the site. So however you see the storm water leaving the site, it could be in a number of different ways, but as you get more and more familiar with a specific site, you understand kind of where the low spot is or where the discharge location is. I mentioned the major difference between a risk level 1 and a risk level 2 project is the stormwater sampling. The other more minor difference is risk level 2 projects require what's called a REAP, and that stands for Rain Event Action Plan. And that is required when precipitation of 50% or greater is predicted on your construction site. Luckily for you and luckily for QuickSwip, we have an automated REAP system in place. So the QSP won't have to worry about creating the REAP. They'll just receive it. And it's also a reminder for the QSP that, hey, storm is coming, and kind of helps them get prepared. A storm is categorized as less than a 48-hour break between storm events that record precipitation. And the example for that is, let's say it rains on Monday and it doesn't rain at all on Tuesday. It's a sunny day. But Wednesday it rains again. That's only a 24-hour break between recorded precipitation between Monday and Wednesday. So the Monday and Wednesday precipitation amounts get added up together and becomes the same storm. So when it comes to discussions about is it half an inch of storm, well, you add up Monday's precipitation and Wednesday's precipitation, and that is the same storm. And if it's over half an inch, then at that point, you'll do a post-storm inspection report. All things related to SWIP and weather forecasts and past weather, all done through NOAA. NOAA is a government website. It's not done through weather.com or any other weather application you find on the internet or on your phone. The official forecasts, official rain data will come from NOAA. Now, some sites will have their own rain gauges on site, and you can get even more accurate numbers. But typically what we'll do is you'll look at the nearest NOAA weather station to your construction site. So, for example, if we have a construction site in Pleasanton, you'll pick Livermore as the nearest NOAA weather station, and that way you'll obtain your forecast and you'll obtain any past weather information. Within the QSP cheat sheet document, we go into detail on how to determine forecast weather and how to determine past precipitation. And that's something that we're not going to go through in this video. It's a lot easier to go through via the document, and as the QSP, you'll get a lot more hands-on experience, and you'll be able to remember the procedures to go through determine forecast and past precipitation by logging onto the computer yourself, navigating to NOAA, following the steps in the QSP cheat sheet to obtain the information required for forecast and previous precipitation. In this section, we're going to go over what to look for when you are out on site conducting QSP inspections. It's going to get broken down into a couple different phases. First one's going to be weekly site visits. So when you're out on your site on a weekly site visit, there's no rain. Let's just say there's no rain, beautiful blue skies, your first time out on the site. What are you going to do? So your first time out on the site, you want to look at the SWIP and understand what BMPs are supposed to be out on site today. Within the SWIP, there is a stormwater control plan. It has to be part of every SWIP has a stormwater control plan or an erosion sediment control plan. And you want to understand, what are the perimeter BMPs? Is it fiber roll? Is it silt fence? Where is the construction entrance? Where is the staging area? There's a lot of things that initial stormwater control plan will show, and it'll help give you an idea when you actually do go on site what to look for. There is a list that we're going to go through of the common BMPs to look out for on a construction site. Always number one is vehicle tracking. Vehicular tracking is when a vehicle is on site and it's in the dirt and it leaves your construction site. Does it take sediment with the tire tracks? I guess the tire tracks go down the adjacent street, and the sediment filled the adjacent street because of the vehicle leaving your site and tracking all that off site. That's the number one way a site can draw negative attention to itself. And that the reason is because neighbors, people that live nearby, see a dirty street and they go like, what is going on? Why is this construction site not taking care of, just general cleanliness and maintenance? Why do I have to see all this mud and gunk leaving the site on these city streets that I'm a taxpayer? I pay a bunch of money to keep these streets clean. So that's my number one thing that I tell clients when I get to a site. I always tell them to look out for vehicular tracking. Make sure you have sweeper trucks coming by, vacuum trucks, maybe you even have manual labor, people with brooms on the adjacent roadway sweeping all the sediment off the street, because the last thing you want is to bring unwanted attention from a state or local inspector to your construction site. The other major way that you can bring unwanted attention to your site is if you have uncovered stockpiles or just really fine dirt or sediment on your construction site, and it gets kicked up during wind. When a gust of wind comes by, there is a BMP for that. It's called wind erosion BMP. And again, it's the same thing. It's a neighbor nearby, a local business nearby. There's sediment or dirt blowing onto their site or their roof or their windows they just washed, their car they just washed. They don't like it. And again, that's a quick way to get unwanted attention to your site. So there's BMPs to mitigate for that, and there's BMPs to mitigate for tracking. I wanted to bring that to your attention first and foremost. No matter what construction site you're on, risk level 1, risk level 2, risk level 3, the two major things to look out for are sediment tracking and wind erosion. So sediment leaving your site due to wind. The other more common BMPs to look out for when conducting weekly site visits are fiber rolls. Are they located where they're supposed to be? Are they staked properly? Are they overlapping? We'll go into another perimeter BMP is silt fence. Is it actually embedded into the soil, or is the bottom of the silt fence above grade, which doesn't really do any good because the water's just going to go right underneath the silt fence and it's not going to capture any sediment? There is the construction entrance exit, sanitary facilities, dumpsters and trash bins, making sure they're covered, concrete washouts, dust control, which what I spoke about earlier, chemicals and secondary containment or in covered areas, stockpiles, and that's a stockpile is dirt that is just built up and has a little mound or a kind of a mini mountain, and paints and chemicals if they're stored in secondary containment and in covered areas. And lastly, storm drain inlet protection. And this is to dive in and give a little bit more detail into the list of the BMPs that a QSP should be looking out for. The construction entrance exit per the BMP fact sheet should be 50 feet long. Is it always 50 feet long? No. What's more important is the construction entrance exit doing its job? Is it removing or releasing excess sediment, built up mud on tires as it rolls through the construction entrance? And is it minimizing the amount of sediment that leaves the site or is tracked off site? So I don't always focus on the length. I more focus on how it looks. A lot of times these construction entrance exits can get filled with fine sediments, and over time it get kind of compacted down into almost like a pavement. The whole purpose of a construction entrance exit is to have really big jagged rocks or large pieces of aggregate. So when you do drive over them, you're shaking off all the sediment from the tires, from the wheel wells, and it should be a bumpy ride. If you see vehicles traveling over a construction entrance exit and it's kind of a smooth ride, that construction entrance exit needs some maintenance. So maybe they need to put a new layer of rock down. Maybe they need to add what's called a rumble strip. It's basically steel that is welded in a fashion that kind of goes like little mini mountains, almost like little V's. And that's another way to loosen sediment from your tires and from the equipment as it goes on and off site. Sanitary facilities, so that's the portable toilets, portable hand wash stations, should all have secondary containment underneath them. And what that is, the purpose of that is in case there's an accidental spill, if there's an accidental leak, that doesn't go into the storm drain system or get off site. It stays within that secondary containment area and it gives a chance for the maintenance crew to come by, vacuum up whatever has been leaking and dispose of that sanitary facility and get a new one. The concrete washout is the same idea. When concrete is being poured, there's a lot of tools required to get the concrete in place, and eventually those tools need to be washed off so concrete doesn't harden on those tools. Now, you can't just wash those off onto your site without them being contained. The reason why is concrete, or the main ingredient in concrete, the cement, can really spike the pH in receiving water bodies. So the purpose of a concrete washout, typically what you'll see is those small kiddie pools, those blue small kiddie pools, because they're cheap. And what they do is they can wash out into those small kiddie pools and wait for the concrete to harden and then dispose of that concrete. When you don't do that and you just wash it off onto your site, the water from your hose or whatever device you're using to clean your equipment carries that spiked pH off your site easier. Spiked pH as it leaves your construction site is really bad for the environment, negatively affects all the biological life that lives within the receiving water bodies. Dust control, we spoke about a little bit earlier. Again, it's a way to bring unwanted attention to your site if you do not mitigate dust. A very common way to mitigate dust is with water trucks. And what you'll see is a big tanker truck that drives around the site and sprays water throughout the day. And what that does is it kind of packs down the loose sediment, loose soil, and doesn't allow for wind to kick it up and deposit it off site. There are some other methods that you can use, but water trucks is typically the most common way you'll see dust control being done. It's cheap and it's effective. Chemicals, during construction, there's all sorts of chemicals that are used, from paints to glues, stucco material. All these materials get delivered to the site, and it's important that they get delivered and stored in a manner that isn't exposed to the environment in case there is a random storm event that comes by. Give you an example. They should be stored in covered areas, so in case it does rain, the runoff does not come in contact with these chemicals and allow to get off-site. They should, if they're sitting out on the construction site, they should be covered in plastic at the minimum. That way, again, they are not exposed to the elements. If they're in use, they should be within a secondary containment area. If you're spraying stucco, painting, all these materials and all these chemicals should be within secondary containment to prevent accidental spills or leaks. Same goes for fueling containers. Fueling containers, there's a ton of equipment being used and operated during a construction site, but accidentally knocking over a fuel canister or a fueling station could be detrimental to the environment. So the purpose and the idea is to contain everything to prevent any of these accidental spills or leaks. Stockpiles are basically just big mounds of dirt or rock, and it's another item that needs to be mitigated prior to storm events. They should be covered during the summer. For example, if they are unused for 14 days or more, they should be covered. Again, the whole purpose of that is to prevent dust from leaving the site during gusts of wind, windstorms.
We hope you found this video helpful. Thanks for watching.